My name is Mustafa Cankan BALCI. I am mechanical engineering student at Bilkent University. I am taking this video for Physics 101 project. Let's watch the video.
Hello everyone. In this experiment, I aim to find the Young's modulus of the Cooper wire. The Young's modulus is the elasticity constant of the solid. It is the ratio between the stress and the strain. The stress is the force applied by per the cross-section area of the wire. Also, the unit of the stress is the Pascal. Moreover, the strain is the ratio between the original length or between the change of the length of the wire and the original length of the wire. In this experiment, I used 1.80 meter Cooper wire. At the end of the Cooper wire is the stud between the two wooden walls by the help of the G-clamp. In the end of the wire, I use masses for applying the force on the Cooper wire. So I use the pulley and the table clamp to stabilize the plane and also to create the tension in the wire by using the mass. Also, in this experiment, I have got two types of masses. So the data set of the experiment cannot be appropriate. So by adding the masses, I firstly calculate how much gram is this. For example, this is 131 grams. So I take it and it is the magnetic. So I can attach like that. So that I can create more tension force in the wire. In the experiment, I use the tape to declare the point, how the point is changed. So I use the tape to declare the point, and I take this point to in the paper to calculate it. It is the initial point, and these are the change of the points by applying the force due to the force. I want to show one experiment model trial. So I calculate the mass of the wire and I attach it like that. So it creates more tension than before. So I use the pencil to declare the points like that. Like that. So if I want to measure the change of the length, so I use the vernier for that. So I take the first point, initial point, the vernier is like that, and take the final point, the end of the clamp. So for instance, for this trial, the change of the length is to 12.78 millimeter. So tension force is very small because it's very small also. So that's all what I'm going to say.
I forgot to mention the important details about the experiment in the middle part of the video. The independent variable of the experiment is the force applying in the Cooper wire, and the dependent variable is the change of the length in the Cooper wire. The constant variables are the initial point of the Cooper wire and keeping the room temperature stable. This experiment is very sensitive experiment, so I'm expecting more random error than systematic error. So also in the video, in the middle part, I made the miscalculation in there. This is the final data set which I've taken from the experiment. You saw the dataset which I've taken from the experiment setup. So I'm expecting more random error than the systematic error because the experiment is very sensitive, which I'm saying before. So if I can able to use more technical measurement devices, the results came from the experiment setup is more accurate. So thank you for watching.